find the area to the right of 2.40. We found it with calculator yesterday, but let's find it with the chart. Okay, so the first thing I want to do is draw a normal curve. So I'll go to draw a normal curve and show the indicated area. 2.4 is positive. Therefore, it is above the mean. The mean is right here, 0. 2.4 is somewhere here. And I am told to find area to the right. So it is area from here to positive infinity, 1e to the power 99. 2.4. But we know that area under the normal curve is 1. So if the area under the normal curve is 1, I am going to read the standard normal. And when I read it, it's going to give me area to the left. So when it gives me area to the left, so first of all, I will find 2.4. 2.4 is positive, so I'm going to look for 2.4 on the positive side. So that is 2.4 right here. And I want to find the area to the right of 2.4, and that is 2.40. So that is 2.40 right here. So to find the area to the right of 2.40, right here. So the area to the left actually is 0.9918. 0.9918. So since I am looking for area to the right, what I'm going to do is total area under the normal curve minus 0.9918. So I don't really need a calculator or chart, but I read the chart already. So I read the chart, and I'm going to do 1, the total area under the normal curve, minus 0.9918. So my answer will give me the remaining area to the right, because my calculator reads area to the left. Okay, so when I subtract, I have, if I bring here, I have 1.0000, and then I'm subtracting 0.9918. So right here I got 2. Remaining 9 here, 9 minus 1 is 8. And then I have 0 here. The same answer we had from calculator. And therefore, the area to the right of 2.4, standard deviations above the mean is 0.0082. So that is the area. The area is insignificant, but it's still something. If I'm told to find this area in percent, then I will move 1, 2 to the right. So the area is 0.82%. The area under the normal curve, 2.4 standard deviations above the mean, in a standard normal, is 0.82%, the same thing as it was in the calculator. Okay, so let's read area to the left. So how do I read area to the left with the chart? How do I read area to the left with the chart? Note that the chart gives me area to the left anyway. So what I'm going to do now is pull the chart up, look for. So I'm looking for area to the left of negative 0.46. So I pull the chart up, and this area is negative 0.46. So I'm going to be, this is positive here. So I'm going to be looking for negative. So I'm going to pull up. If you're just coming in, we are reading the area under the normal curve using the chart, using the Z chart. So negative 0.46 is this area. So let's look at it again. That is the area negative 0.46, and we want to read from the chart. Okay, so negative 0.46, so negative 0.4. Now we have to travel to the right until we count 6. So how do we count 6? So we count 0, 1, 2, 3, 4, 5, 6. So the intersection right here is that area. Okay, negative 0.46. The area is 0.3228. The area is 0.3228. Area to the left of 0.46. So I'm going to get my go to back. Make sure you draw a diagram. Every question on normal distribution will have a diagram. So draw a diagram representing that area. So I'm going to draw a diagram. And this standard area is negative, so it's below the mean. If the z-score is negative, it's below the mean. So that is negative 0.46. Negative 0.46. Okay, and I'm told to find the area to the left. So area from here to the end. In other words, area to negative infinity. Okay, so we already read the chart. So we have, let's look at the chart again. So we found out it is 0.3228. Okay, so it is 0.3228. So that area on that normal curve on the left of negative 0.46 is 0.3228. 0.3228 in decimal. You could be told to leave your answer in percent. So the area in percent is 32.28. So it's quite easier doing it reading the chart. So you can read the chart. You can actually use your calculator. Okay. Remember that if you are using the calculator, you remember that the calculator does not know about negative infinity and positive infinity. So you must use negative 1e to the power 99. Okay, so area between. So let's read area between with the chart. So now we are going to do number 3, area between. So this is number 3 here. So we want to get another, okay. And then I am told to find area between 0 and 1.28. 1.28 is on the right-hand side of the normal curve. And 0 is the mean. 0 is the mean. The standard score of mean is 0. And 1.28 is positive, so it's on the right-hand side. This is a sketch, 1.28. So I'm told to find this shaded area. So this is area between. Now, how do I read area between from my calculator? So what I'm going to do is find the z-chart of the bigger number, upper bound, subtract it from z-chart of lower bound. Lower bound. So the upper bound is 1.28. So I'm going to pull up my chart now. So I already know what to do. I'm looking for the area, the upper bound, and then find the lower bound. We already know that area to the left, lower bound is going to be 0.000. So 0.5. Let's go ahead and see it. So 1.28 is positive on the right-hand side. So let's get it from, so 1.2. So this is 1.2 here, 1.2 right here. And then we're going to count 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is area to the right. This area to the left of 1.28, and that is 0.8997. All right, we can as well find area when it is 0. The mean, the area on 0 is always going to be 0.5. The mean divides the normal curve into 2 equal parts. So the area of the normal curve is 1. So from the mean, that area is 0.5. Okay, so we go ahead and do the calculation. So let's calculate. So the upper bound is let's go back and get that. Okay, so that's 0.8997. So 0.8997. So 0.8997 is right here. 0.8997. So area of the upper bound is 0.8997. Area from 0 is 0.5 because the normal curve, the mean divides the normal curve into two equal parts. The area under the normal curve is 1. Therefore, the mean divides the normal curve into two equal parts, which means divides 1 into two equal parts. Okay, so now I'm going to subtract the area of the upper bound minus area of the lower bound. And if I subtract, I got 3 here. And I have 9 here. 9, 7. So the area between is 39.97%. So 39.97%. If I'm told to leave my answer in decimal, maybe to 1 decimal point, I'll write 0.4. So anyway, the area is 39.97. So you can now use your chart to find the area between, area to the left, area to the right. Okay. All right.